Alright, I've been building these very simple transmitters for fox hunting for our ham radio group. And we've got a large CB radio group here that wanted me to make a video showing how I'm making these. This one's a low power, can run off 1.5 volts up to 12. Can get a quarter mile, half mile range, depending on the height, the antenna, and voltage. But it's a very simple circuit, and it'll act as a beacon. It'll pulse every couple times every second. So I'm just going to get into it here. First part you'll need is a crystal. This is 27.125 megahertz, which is, that's in the CB radio band, somewhere low. So we'll need our crystal, and then our inductor, which is 9 turns of 18 to 22 gauge copper wire wrapped around a 6mm drill bit, spaced out over 15 millimeters or so. It's not that critical, as long as you can tune it with, I usually use a variable capacitor, but I'm going to be using this 120 picofarad capacitor, as that, I know that's, we'll tune this for 27 megahertz, or it should be from my calculation. And then to create the pulsing, we'll be using electrolytic capacitor. This is 3.3 ultrafarad electrolytic capacitor in series with a 4.7K resistor, and that will give us our pulsing. And then we got a 220K resistor and a very common transistor, the 2N2222, which we'll use to put that back. Alright, so I'm going to get into it here, how I lay out and complete this very simple circuit. It'll run off 1.5 volt batteries, such as it'll run off a AAA, a AA, or you can use a bigger battery if you want more power and longer life. So the first thing I'm going to do here, I'm going to use, cut out some copper clad little pads here. I'm going to super glue these to the board. So let's start with our first one. Put it somewhere around here. Let that one dry. Our second one will be next up in line. Our second one, right about there. Our third one, same thing, just up in line. Our fourth one, continue the line. Nope. Let's get that set up a little. And our fifth one here is going to hold our inductor, so let me measure here and see where. Go right around there. I put my pads down, super glued them. Now we're going to solder. Put some solder on these pads so I add a little flux. Kind of tin these pads here to make it easier for us. Let's put some solder on it. Put a little more on this pad. This is going to be holding our inductor coil. I'm going to go ahead and fill that one up. We'll have multiple components. Finally, our other inductor pad. Alright, so we have our 4 pads down. Get this lighting a little better here. Clean this up with a little alcohol. It's not that important, but alright, so now we can start soldering some components. I start on this first pad here with our electrolytic, our 3.3 electrolytic capacitor. I'm going to solder to our first pad and then to ground. So let's get a little solder and check the polarity on your electrolytic. Mount this right here, and we'll put a little flux and mount this to our ground plane here. Just like that. Got our electrolytic going from the first pad to ground. Next, we're going to use our 4.7K resistor, which we're going to install this resistor from the electrolytic capacitor to our second pad. This is 4.7K resistor. And you can play with these two values here to create a little different beacon, little different intervals, different characteristics. If you use maybe a 4.7, and then this is, you could use a 6,000 ohm resistor, 7,000 ohm resistor, and play with these two values. But I know 3.3 electrolytic and a 4.7K resistor work good, and I like the output, so we're going to stay with that. So let's solder this on there. Let me turn this around. Put our resistor in line from here to our second pad. Push that down. Alright, so now we have our electrolytic, and our resistor going from the same first pad to our second pad. 3.3, 4.7K. Next, we'll add another resistor. This is 220K. We're going to solder that from our second pad to our third pad, just keeping the line going here. So let me move this and solder. Got a hold of this resistor here. We're going to put it right here. Let's bend it up a little bit. And solder it to our third pad. Good enough. Just doing this as a quick little simple demonstration so you guys can see how I'm building these and how simple it is. So 3.3 electrolytic, then we got our 4.7K resistor, and next we have our 220K resistor. Now we can get a better angle there. Good enough. Now let's install our crystal before we get too far. This crystal is going to lay on the board here, and one of these leads is going to come over to this pad, which we could solder that directly to the pad, but I like to add a little wire to these, so I'm going to solder on a little wire. Makes it circuit doesn't get so crammed and hard to work with. So I just solder two little short wires on here. Something like this. Got our two leads. Gonna set here and run one wire to this pad, and the red wire is going to run to our second pad right here, in between the two resistors. Let me grab my cutters and we'll put this up here and cut pad there, and then we'll run this one. Let me strip these real quick. Strip these just a little bit. And let's solder it down in place here. I'll take this red wire and bend it back towards that pad right there. I'm going to put a little flux down here. Let's solder this crystal in place here. Holder. And our second wire. I don't want to heat these small components up too much, or I'd reflow the entire pad, but not really necessary for this demonstration. Alright, so we have, let's see if that'll focus. We have our crystal now installed into our circuit, back to our second pad here in between the two resistors. Because our inductor needs to go over like this, which you can't see. So I like to do the crystal first so it doesn't get all crammed up and it's easier to work with. Alright, so let's install our inductor. Put a little flux down for this one. Our inductor is going to go from this third pad back to this other one with the black wire. Let me hold this inductor. 9-turn inductor. See if you guys can see it here. Solder this in place. Gotta go from our third pad back to this pad right here. Hold our inductor up. Alright, so now we have our inductor. We have our 3.3 electrolytic running into our 4.7K resistor up to our 220K resistor, which shares the same board as our inductor. 9 turns going back to this pad here with our crystal going to each one. A different view here. You can see our inductor. Now to tune our our little L network, I'm going to add a 120 picofarad capacitor from this pad with our inductor to the ground, or ground plane. So add a little flux on here into our ground plane. And let's solder this 120 picofarad. If you're using a different frequency, you'd want to use a different a variable capacitor so you can find out what you're, replace it with a fixed one once you know. But I personally usually put a variable capacitor right here. That way I can tune whatever frequency I want. Alright, got our capacitor soldered there. Now let's solder it to our ground plane. And that's it. Got our 120 picofarad, which will tune between 9 turns, and 120 picofarad should be perfect for 27 megahertz. Alright, our last component we have here is our transistor, which is 2N222A. Looking at the flat front side of it, you have emitter going from left to right. You have emitter, then your base, then your collector on the right. Emitter left, base, collector. So our emitter is going to go to ground our base is going to connect to this red wire here, this pad, and our collector is going to connect to the other side, our other pad, which runs to the crystal also. So let's set this in there, kind of bend these to get them. It's going to sit just like that. Emitter going to ground. The base is going back to our number 2 pad with the red wire, and our collector is going to our pad with our inductor on the other side. So let's solder this little bitty thing. Let's solder this little transistor in place. Get our emitter to ground. Oh shoot. Let's try this one more time. Emitter to ground. Base going back to our second pad here. This thing's giving me a little trouble. Our base. Get a smaller iron tip here. Okay, we've got our base soldered onto that terrible looking solder job, and our collector, we're going to solder that right here. Alright, so we now have the transistor in place. Emitter to ground, base to our second pad, and collector to our pad over here. Let's double check it's strong, it's in place, and that's it. Let me turn on my transceiver here and put in the frequency. We're going to do 27.125. No antenna hooked up. And now finally, when this is complete and you want to run your antenna, some people like to tap it off the coil, but I like to run the antenna from this pad right here. I run my antenna wire out. I connect the ground to the board for the ground plane. If I was going to make a dipole, this would be one side, and then this would be your other element right off this pad with the 120 picofarad capacitor. So we're going to try it with no antenna installed. Now this pad right here is where I usually run in the voltage and I jump it. So let me add a little jumper. I'm just going to use a little piece of resistor wire or resistor metal. I'm going to jump this pad to this pad here, which is getting pretty full and hard to get to now. But that'll work. Not the greatest looking, but usually I'm OCD with these and I make them perfectly straight and nice, but I'm just doing a quick example here, trying to keep this video short. So all I did was jump these two boards together, because I like to bring my voltage into this first pad, and maybe use like a little 10 nanofarad capacitor, a little 102 or something. But for right now, we're just gonna try this battery here, which is 1.5 volts. So we'll go ahead and do a test here. Let's solder the negative of our battery. Just put it right here for now. I've run these off solar panels, directly off solar panels, or 3-volt batteries with solar panels, 6 volt, 9 volt, 12 volts. All depends what range you want and what you're trying to get. So now I'll take our positive wire. It's going to connect to our, you can hear the beacon will start going here. Let me connect that. Should solder it. Hold on 1 second, I'll solder this into place. Alright, so we're going to solder this positive as you can hear, it's working, and this is the result. Turn that down for a second. So our electrolytic capacitor along with this resistor is creating that pulsing, and then we're using our inductor 9 turns of copper wire with the 120 picofarad capacitor to resonate, and a little 2N2222 transistor running off 1.5 volts here, and you can hear the output. Which will pulse a couple times a second. Perfect for fox hunting or not making a jammer out of, as a couple people have done in the past, which I don't recommend. But at this low power, this range within a little, I usually just take a piece of wire, let's see, for 27 megahertz, a quarter wave, 8 point something feet, 8.5 feet or so. Just take a piece of wire 4 to 8 feet long, hang it down from wherever you hide your transmitter. Get this to focus here. And it'll cover a quarter mile. I've had it cover a mile before when I mounted it up in a tree. Focus on me here. Let me focus this camera. So depending on the voltage, if you want to use a 9-volt battery here and a quarter wave piece of wire antenna, you can easily cover a large park or wherever you're fox hunting. And here's your output. Let me go back to 27 megahertz. which you'll be able to hear it on AM, FM, change it back to AM here. CW, it's creating a CW pulse. And then on some of them I'll build a 600 hertz little multi-vibrator circuit to give it more amplitude modulation. Or I have a quarter watt version where I add a little amplifier section, maybe a little buffer to give you a little better transmitter beacon. But this is it. Here's a larger battery we have here at 6 volts. Signal didn't change much, it's still full. And this is the output. Very easy, very easy beacon. And if you wanted to add an antenna, come over to here and run your antenna. From this pad here. And run your antenna out. And there you go. That's it. It's quite loud on it. Add a switch into there. But it's very, very easy to build, very simple circuit. And you can play with these two values of these components, this capacitor and this resistor, to give you a little different output. Same with the coil. You may get faster or slower, or it's speeding up there. And that's all there is to it. Get this to focus. On my next video, I'm going to build a little larger circuit that's about a quarter wave or a quarter watt, has a quarter watt output, and add our little multi-vibrator circuit here to give it more amplitude modulation, so you're not just breaking the carrier, but you're also pulling, giving amplitude modulation for AM and other radios. You can hear it AM, FM, sideband, CW. Well, that's it. You guys wanted to see how I build it and how simple it is. That's all there is to it. All right.